Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 1-3 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to understand equations with infinitely many or no solutions. This example actually starts out with a video from Savvas, so if you have the online textbook, I highly encourage you to watch part A, which is what this first problem is, as the video in Savvas, but I will go through this problem as well. All right, so the goal in solving these types of equations is to get the variable x by itself on one side of the equation. And so looking here, you could see, it's not showing my mouse, there we go. So looking here, you could see that there's an x on each side of the equation. Now, I tend to lose track of my equal signs, so I'm going to go ahead and draw this little river here, which helps me to make sure that I know which side of the equation each letter and number is on, and it helps to keep things organized. Now, this variable, this is stuck inside of these parentheses. So my beginner step here will be to distribute this 2 so that the parentheses kind of open up. Sorry for my handwriting here. This is not so hot. So I have 4x, and then 2 times 3 is 6. Okay, so now that I've done that, all right, you could kind of see I have the same thing written on each side of the equation. Now, I do want to go all the way until the variable cancels out, because if you haven't gotten the variable alone, you haven't solved it. So I'm making the effort to move this 4x to be on the same side of the equal sign as the other 4x. However, 4x minus 4x cancels out, and so that's where I get 6 on this left-hand side, and here it cancels out because I moved it, leaving me with 6 here on the right-hand side. So in this expression here, I am left with a number equal to itself. So there is no variable. So whenever your variable completely cancels out, that's what leaves you with IMS, or no solutions, okay? So to get infinitely many solutions, that's a T, it's just ugly. To get infinitely many solutions, you have to end up with a true statement. All right, this can't be a lie, it has to be true. To get no solutions, we have to get some kind of expression that is false. So for example, if this said like 6 equals 74, those two numbers aren't the same, so that wouldn't be false. So in this case, 6 does equal 6. So in this case, you get infinitely many solutions, which many kids write as IMS. All right, and so now we're just going to practice with a few more of these. Okay, I'm going to end up zooming in a little bit. Part B here just asks you to find the value, and it's going to solve it out the same way. Okay, so we're going to start with our wonderful river of Algebra 1 student tears. All right, so then we distribute here to the parentheses. Remember, the point in that is to break this variable out of the parentheses. While it's trapped in there, you can't combine it with the 6x that's on the other side. So 2 times 3x is 6x, and 2 times 4 is 8. All right, and then you have to try to move the variables all onto one side. So this 6x, I'm going to attempt to move to the right-hand side. It's currently being added because it's a positive number, so I'm subtracting to move it. So here on the left, 6x minus 6x is nothing, leaving you with negative 5. Here on the right, 6x minus 6x is nothing, and that leaves you with a positive 8. And so you have to look at that and ask yourself, is that a true statement or is that a false statement? Well, negative 5 does not equal 8. So that is a false statement, so you would say no solution. I know that one thing that my students struggle with is they'll say true or false, not infinitely many solutions or no solutions. True and false is not an answer. It's either infinitely many solutions or no solutions. So these are the try it, right? These are the ones that your little workbook has space for if you have a workbook. Now, here I have a negative sign in front of the parentheses. That's like -1 times the parentheses, and I'm just going to distribute that. And so when I do that, my left side stays the same. But what that does is that changes the signs here inside the parentheses. For the sake of keeping things in order, I'm going to write it out like this. But it is worth noting, you could just flip that around. Like this is the same as saying t minus 27 here. Okay, that's the commutative property that says that you could add or subtract in any order. Or sorry, that you could add in any order. Subtraction, not quite. This turns into subtraction because of the negative on the 27. So these are the same thing, but many students tend to not write this part, or they tend to not write this part. They go with one or the other. But having done that, right, I'm going to try to move my t's to be on the same side. That's a t, it's just funny looking. And t minus t is nothing. So on both sides of this equation, the t's are canceling out. So on the left, I'm left with -27, and on the right, I'm left with -27. And then you ask yourself, is that true or is that false? Well, that's the same number equal to itself, so that's a true statement. So that means that this equation has infinitely many solutions, or IMS. You want to be careful if you say IMS a lot, though, because a lot of kids tend to forget what the letters stand for. So they'll recognize IMS, but then they don't know like what that actually means. All right, now this one has parentheses on both sides of the equal sign. And so having parentheses on both sides means that you have to distribute twice. You have to distribute the 16 to this one and the 96 to this one. Don't be afraid of that fraction, okay? Right there, that's just division, okay? So on the left-hand side, I'm just going to take out my handy-dandy calculator because I don't know how to multiply. 16 times 4 is 64. 16 times 3m, 16 times 3, I want to say is 48. I always use a calculator just to check that I'm doing it properly when it comes to these big numbers because I'm not always sure. And it's easy to make small arithmetic errors. All right, now here I have a positive number times a negative number. So whatever this is, it's going to be negative. It's going to have an m in it. We just have to figure out what number goes there. All right, so I'm multiplying the 96 to the m. So I'd have a 96 here up top and a 2 down below. So I'm actually doing 96 divided by 2. I wrote 43 over there. Goodness gracious. Anyway, 96 divided by 2 is 48 as well. And then 96 times 1 is 96. So my next step is to try to get everything with an m to one side. So this -48m, I'm going to add to attempt to move it to the left, which is canceling out with this -48m that's already on the left. So that leaves me with a 64 over here. And on this side, I'm left with the 96. Then you ask yourself if it's true or false. Does 64 equal 96? It does not, and because that's not a true statement, there is no solution to this equation. And there you have it. That is how to deal with equations with infinitely many or no solutions.